Hi there, welcome back for another how-to guide on working with statistics. Today we're going to look at the idea of how do I interpret data sets looking for what the better measure of center, as well as how do I create visual models like interquartile ranges and dot plots to be able to kind of better interpret my data. So to do this, we're going to look at three apps today. We're going to look at StatKey, we're going to look at Desmos, and we're going to look at a website called GeoGebra. Each of those is linked into the activity you're going to do in class. But I wanted you to have all of them by name. And they're also linked on this slide so that if you're at home working on your summative in the future and you want to come back, go back to the lesson slides and you can find the link for that. So as I exit the slide deck, I'm going to jump into, so what I made here is I made just a sample set of Likert scale data with the idea that this subgroup you can see shows up in the whole sample, and the second subgroup is the second part of that sample. And we're going to look at how might I make box and whisker plots to look at interquartile ranges using StatKey as well as Desmos. And then we're going to look at how might I make a whole group dot plot or a dot plot for each of the two different subgroups, 1 and subgroup 2, using the website GeoGebra. So we're going to first, in order to make a box and whisker plot, we're going to want to select our data and copy it. And after I've copied it, and the reason why I'm using Likert scale data instead of some of the other data you'll see in the activity today is I want you to also be able to use this as somewhat of a guide as you jump into your summative project, and you may want to incorporate visual models of different kinds. So for StatKey, I go and when I look at what's called the one quantitative variable data, when I start to look at that, I need to edit the data so it's the data that I'm working with. So I Command A all that, delete it, unclick both of these guys, then it makes it work a little bit more functionally, and hit OK. So what I see right now is this is what a dot plot of that data looks like. We're going to go look at that later on GeoGebra because I think it's a little bit better interface. But what I do want to highlight is you can also look at a histogram, which looks like this, or we could choose to look at, in this case, a box and whisker plot. We notice there's not really a whisker on the left-hand side or any stretch of that second side line because I can see in the data here that the minimum value and quartile 1 are both 1. What I do like about StatKey is this really nice, friendly legend of summary of your statistics. So it has from your sample size to your mean to the standard deviation to everything about your interquartile range and your box and whisker plot. And so I can see here that the median for this data is 3, which is right here, and then my mean, which is about 2.5, which would be right here. And we're going to look and talk a little bit more about center when we get to the dot plot. But if I wanted to get a screenshot of this to use later, I just do Command-Shift-4, and then I would select and screenshot that. And so I've actually done that ahead of time. So what I can do here is whenever I want to insert something into a slide deck, or into, a sheet, I just insert into the cell. And then we're going to go back here in a second, and we're going to grab that off my desktop. And it should be, I believe, let's see here, let's go with icons. Is that going to give me what I want? Nope, lost what I was looking for. Let's not do that approach. We can actually do this one here because we know we just took that one. So I'm going to insert that image. Sorry about that. And you can see that at this point there is eventually, wait for it, my box and whisker plot. So now I have box and whisker plot that we're going to compare that to the dot plot to kind of decide which one maybe is a better representation for us to see. Now, to look at the second group, we're going to use Desmos. So we're going to copy this set of data. In Desmos here, which is again linked in the activity today, when you go to Desmos, this is what the website looks like. And if you select the data next to A and delete it and paste in your new data, you can see it produce this box and whisker chart. Now what's cool about Desmos is you can grab and drag the page and then zoom in with 2 fingers, and it's very user-friendly. What I also like is I think visually it's a little bit more aesthetically pleasing. And so I'm going to do a screenshot of that one, just like so. Now, at the same time, it does offer similar information that you saw on StatKey, but you just have to unclick this part here that says random stuff about your data. I love how truly real it is to say it that way. So I can see here that the mean of my data is 3.2 and the median is 3. And we're going to come back and kind of think a little bit about that through the lens of our dot plot in a little bit when we try to decide which might be the better measure of center that we're going to look at. So just like before, we're going to come back here and we're going to put in our box and whisker plot. Oops, we want to go insert image into cells, and then it will slowly get there. There we go. And so here's the new image that I just took that's going to insert from Desmos, or from Desmos. So you can see, I like the Desmos image because I think it's a little bit visually a little bit clearer image and a little bit nicer image than the scaling and the way that this one zooms in and out. Second thing we're going to do is we're going to produce a dot plot. And so to do a dot plot, we're going to go to GeoGebra. And on GeoGebra, you just take your data and you just paste it in. So if you think about working on your summative project, you can just take your whole column of each subgroup or your whole sample and paste that in. And what's nice is the initial layout in GeoGebra is a 1 to 10 scale. So there's our 1 through 5 Likert scale. Second thing that's nice is it also gives you that important information in mean and median. And standard deviation, we're really not going to spend a lot of time on in this unit or in this project. So I'm actually going to go ahead and just delete that because we don't need it. But as I go back to my data, and to find those, you go to columns E and F over there. They're the coding's laid aside. So I can see now, here's my dot plot. And I notice that the ones in relationship to the majority of the data over here at 3s and 4s, that's going to cause the data to skew to the left a little bit. And so we're going to talk about the impact that has. If you notice on the mean here, the mean's 2.5, but the median's 3, which would be here. So the mean would be about in the middle of these two, but really that's being pulled that way because of the ones. So in this case, the better form of center might be, or the better measure of center might be using the median. So we're going to go back, we're going to insert that into our image here. Now remember, if you're doing this on a slide deck for your summative project, you wouldn't need to insert this way. You could just open in Command A, Command C, all of the image into your slides. I'm going to go through kind of that same process one more time, actually a couple more times, one more time with this second subgroup. And so as we go back here, we want to restart everything. So it's going to clear it out. Notice standard deviation did show back up. So I'm going to come over here and get rid of that. I kind of find it annoying. Now, if you look at this graph is a lot more symmetrical. Now, it's not perfectly a mirror symmetrical because of this guy over here at 5, but really overall, it's a very symmetrical looking graph, and there's not a big tail pulling. The mean goes slightly to the right. So in this case, really the mean or median is going to be a good form of center, and I'm more apt to probably use the mean, mainly because the mean then takes into account the 5 as well as it takes into account all values, instead of just being that middle value. And so just like before, we do our screenshot from 1 to 5, so all of the values of the Likert scale are available, and we would come back here and paste that in. Now, what I really like to notice in this is where the interquartile range is really nice to think about the idea of where 50% of that data is. Where you might notice really, especially in this first subgroup, is even though the median was here, the interquartile range is really skewed well to the left because of these values. So if I was going to think about kind of the best measure of center, or the better measure of, excuse my spelling, measure of center, I would probably use the median because of the data skewed to the left, and again by outliers at 1. Now that may be the case as well in your data you're working with on your project, but then again it may not be also, and I'm going to merge these real quick because I want to be able to see that a little bit more clearly. Now over here, if I think about this data, I can see that the interquartile range is pretty central. We said that our median value was 3, that our mean was 3.2, and so I forgot to put here the median value in this case would be 3. The mean value would be 3.2. So as I think about that, here the better measure of center I might use is the mean, which was 3.2 because all of the data is included in calculating, and the data is fairly symmetrical. So I can see again that it's kind of making that almost bell curve type shape here. So that's going to let me know I probably want to use the mean. Now what's also interesting is if we look at the whole sample. So again, we could do the whole sample if I go back to StatKey, but I want to show you kind of my bias opinion in this. So if I go back to StatKey, I put in my data and I make my my dot plot, again, I can see all the data, but because of these really high quantity numbers on the left-hand side, it's not really that visually aesthetically pleasing. You can see that the mean was 2.85 and that the median's 3, so those are pretty close and similar. But I'd rather come back over here and I'd rather paste it in, and we're going to move. So I have the same mean, 2.85, and median, and now I can see it is a lot more symmetrical than it was before. And because of the number of data points involved in the image, and because of the fact that I want to involve 1 and 2 if possible, a mean of 2.85 compared to a median of 3 isn't dramatically different. And again, it does incorporate all the data, so I might be more apt to use a mean of 2.85 in this situation. So we're going to add in our last visual here. But really the goal of spending a little time in this video was to show you how do I take a set of data like you might have in your project, and how do I turn those into visuals, and then how do I stop and think a little bit more about that visual situation. And so again, this one I probably might pick the mean of 2.85, though I could completely understand an argument that does include the outliers of 1 over here, but it really is the full set of data involved in that story, and it's fairly symmetrical, but it is impacted by 3 outliers at 1. Median is 3. So if you were to argue the median there, I wouldn't necessarily see it to be wrong either. So I want to just, again, give you a chance to see kind of the different ways you might do this, and the different platforms you could use to start to play around with the visuals on your project. I'd encourage you to spend some time playing around with these, figure out which one makes the most sense to you. My advice is, when it comes to box and whisker plots, I think the Desmos one is really great. I think the thing you do have to be careful of is to make sure that you delete the prior data before you enter the new data. When we're looking at dot plots, I definitely would encourage you to use GeoGebra. All right, thanks for taking time to watch the video.